Greetings everyone, Professor Simon here, ready to talk about more factoring methods. Let's jump into one of the most used factoring methods, and it's called the trinomial method, simply because the polynomials that we apply this to are in fact three-term polynomials, trinomials. They're usually of the form ax squared plus bx plus c, although there are a few slight variations, and I'll throw those out and you'll see them coming as I'm doing them. Okay, the first type that we want to talk about, there's two types to sort of categorize them and build on this skill. The first type is when the first coefficient here, a, is just 1. Okay, so this is the beginning, the basic version, right? So to begin, remember factoring is unmultiplying. I want to talk about the multiplying part, right? So you've seen this before. You've multiplied two binomials before, and we typically, use catchphrases like FOIL and first, outer, inner, last, and things like that. Just remember, it's all distributive property. I'll be doing x times x, which is x squared. I'll be doing x times 5, which is 5x. 2 times x gives me 2x, and 2 times 5 gives me 10, which after that, the 5x and the 2x are like terms and can be added, giving me the trinomial x squared plus 7x plus 10. This is what we want to reverse. Okay, this is the kind of multiplication that we are doing the opposite of. We are unmultiplying. We're unfoiling, if you will, these particular polynomials. So notice the pattern. 5 and 2 were originally the numbers in the binomials with the x's there. And you should notice that 5 plus 2 is 7 and 5 times 2 is 10. Naturally, we're the ones that did that, right? We added 5 and 2. We multiplied 5 and 2 to get those things. But this is the pattern that I need to call to your attention so that we can reverse the process. When you're looking at one of these trinomials, this is what you need to figure out. What two numbers can both add to the b term and multiply to the c term? The constant term and the linear term is what they're also called, right? If they can add to the linear or middle term and multiply to the constant term. Okay, and I've got a little routine to help you get into the mode of this particular, well, it's kind of like a puzzle, a game. Just got to learn to play it enough, and then it'll start coming to you more naturally. So let's start with this one. X squared minus 14x plus 33. Okay? So here's where you want to go first. You always want to go towards the multiplication side first, because to add, to get something, there's really just an infinite list of things that could be possible. It's always better to start on the multiplication side, because we know for now especially, we're mostly using integers, whole numbers, right? Numbers that don't have decimals, fractions, things like that. And so there's going to be a very limited list of things that multiply to get the constant term here. So this is what I do. I write a list on the side of things that can multiply to this number. So let me make a little separator here. I'm going to say what multiplies to 33. And I do what's called an exhaustive list. I just go ahead and list every possibility, including negatives as well. Okay? Now since 33 is positive, that means it's either positive times positive or negative times negative. And I count. So in other words, start with 1, just like you're counting. 1 times what? Sure, times 33. 2, no, 2 doesn't go into 33. 3, yeah, 3 times 11, right? 4, no. 5, 6, no. 7, 8, 9, 10, 11. Oh wait, 11, right? But I've already done that one. So I switch to negative 11. negative 11 does go into 33 negative 3 times. And here's the trick. Once you've hit the same number again and swapped over, the list can just start counting down, okay? So since the only other one I had was 1 times 33, that means the only one down here is going to be negative 33 times negative 1. So it's like a mirror image of the, imagine there's a little dividing line here, right? Once I hit that wall and reverse, I know I just have to mirror image the other factors I've already found, okay? So now my goal is to just pick one of these from this list that add to get negative 14, because I've already gotten it from the list of things that multiply to 33. They just need to also add to negative 14. Remember, they need to do both, and then those are the two numbers that you need. Okay, so then what I'm going to do is just look through this list. They have to add to a negative, so it can't be either one of these. And then I'm noticing, hey, negative 11 plus negative 3 happens to be negative 14. Okay, great. So here's one thing that's really nice about the type 1. I can just write the answer from here. Now what I'm going to do is go through the algebraic steps and show you how I can get to it, because that's going to help us in a minute. But also just know for the type 1s, and I'll do it on the next one, once you identify the list member, you can just write the answer. And that's, the nice thing about these type 1 trinomials. But here's the steps. What I do is I unadd. Okay? I unadd the negative 14. So I have x squared minus 11x minus 3 plus 33. Oops, 3x. So notice negative 11x and negative 3x, they do add back up to negative 14x. And I specifically picked the ones from my list that multiply to 33. And what you've created now is something that can be factored by grouping. Okay? So x squared minus 11x share an x, leaving me with x minus 11. I match the middle sign. These two both have a 3 that I can factor out in common, leaving me with x minus 11. Notice the minus here because 33 divided by negative 3 is negative 11. Both of these have x minus 11, so I factor that out. And I'm left with x minus 3. Like so. And here's my factorization. Okay? But ironically, or maybe logically, holistically, whatever way you want to look at it, notice it's the same numbers, negative 11 and negative 3. Like I said before, on these type 1s, I can literally go straight to the answer. Okay? This is one of the processes that you can use, okay, if you like seeing all of the steps and things like that. But if you already know that you have a 1 in front of this x squared here, right, if it's that type, then you can simply write the answer. And that's sort of the other way of going about it. When we get to the type 2s, I'll show you both this way and the other more direct way that I prefer to use that sort of match this idea as well. Okay? Let's go ahead and do this one. X squared plus 5x minus 36. So again, I'm going to approach the constant term first because it's easier to make a list of what multiplies to get something like negative 36. So that's what I'm going to do. I'm going to say negative 36, and I'm going to look for things that multiply to get him. Since he's negative, that means I'm going to be looking for positives times negatives, right? And then afterwards, it'll switch, and it'll just be the other combinations there. Okay, so negative 36, I'll start with 1, right? So that's 1 times negative 36. And remember, I'm counting. So 1, 2 goes into 36, right? That would be negative 18. 3 also goes, that would be negative 12. 4 goes, that would be negative 9, right? 4 times negative 9 is negative 36. 5 doesn't go into 36. 6 goes, 6 times negative 6. Now look, I've hit a double. That's also a big flag, just like right here. I hit the same number again. Once I hit a double, I've hit that same number in the same fact. So I know once I hit this, okay, I'm not going to get any new pairs anymore. I can just start matching the things above it. I can start mirroring them. So after 6, the next one's going to be 9, and I'm just going to keep counting up these facts. But I'm going to do positive 9 now times negative 4. Do you see how it's mirrored the pair, but now the 4 is negative, right? So then next, I'll do 12, right, because that's the next one up, times negative 3. Then I'll do 18 times negative 2. And finally, 36 times negative 1. So what I have there, like I was promising before, is an exhaustive method. What that means is I'm going to exhaust every possibility that can multiply to negative 36 while still being an integer, something without a fraction, right? And it covers all combinations of positives and negatives, because that actually does matter in the adding portion, right? The 9 times negative 4 and the 4 times negative 9 are actually different combinations because they add to different sums. 4 plus negative 9 is negative 5, and 9 plus negative 4 is positive 5. And actually, that's the one we need. We need two numbers that add to positive 5. So I'm going to choose 9 times negative 4. And like I said earlier, I can actually go straight to the answer because I'm noticing this is that first type. It has a 1 in front of the x squared. So I literally can just write the answer here. This is equal to x plus 9 times x minus 4. And that's the factorization. That's the answer. Now let's get some more examples and different variations of things that you can see involving these type 1 trinomial factoring processes. Okay, so first example, y squared minus 3y minus 40. All right, so again, I attack the constant term first, and I try to find an exhaustive list. So I've got negative 40, and I'll start with 1. So 1 times negative 40, 2 times negative 20, 3 doesn't go, 4 goes times negative 10, 5 goes times negative 8, 6 does not, 7 does not, 8. There's the skip over, right? 8 times negative 5, that's the repeat fact. So now I've got my little mirror image, right? So next I'll do 10, then 20, then 40. So 10, 20, and 40 are my next three that I'll put. 10 times negative 4, 20 times negative 2, 40 times negative 1. Okay, and I need two things that add to give me negative 3. That would be 5 plus negative 8. Right? 5 plus negative 8 is negative 3. So then from here, since it's that first type where I just have a 1 in front of the y squared, I can simply write the answer, y plus 5 times y minus 8. Okay? Next, a squared plus 6a plus 15. So I'll make my little list with the number 15. That would be 1 times 15. 2 doesn't go, 3 goes, right? Times 5. 4 doesn't go. 5. Oh, we hit that repeat number, so I'll use negative 5 now, times negative 3. And then I'm just going to mirror it. So it would be negative 15 times negative 1. And that's all that multiplies to get 15. So now I just need two things that add to give me 6. Well, 1 plus 15 is 16, so it can't be that one, right? Okay. 3 plus 5 is 8. Nope. Negative 5 plus negative 3 is negative 8. Negative 15 plus negative 1 is negative 16. We've exhausted the whole list. I can't use any of them. What does that mean? Did we do something wrong? No, no, no. That's not what it means. It means that you've hit a trinomial that is not factorable, right? And remember, there's a word for that. This is not factorable by this method. And in fact, this particular trinomial is not factorable at all, okay? And I'm going to say prime as my answer, okay? Be careful with that word prime, and I've said this in another video before, let me say it again. Be careful with that word prime, okay? Just because it's not factorable by this method doesn't mean you haven't already broken something off in a previous method or something like that, okay? When you hit a brick wall of these, it just means that this trinomial cannot be broken down anymore, right? Okay. What's wrong with this one? 30 minus 31x plus x squared. Well, the things are all jumbled around, right? Word of advice. Whenever you're doing these trinomials, always have them in descending order. Have the highest power in front and make sure that you get your typing right. So x squared minus 31x plus 30 is the way this one should be written. Okay? Then I can look at it, oh look, there's a 1 in front, right? It's a type 1, and I can see, oh, I'm going to attack the constant term on the end, the 30, right? So 30, I've got 1 times 30, 2 times 15, 3 times 10, 4 doesn't go, 5 goes times 6, and then it hits the repeat, right? 6. So negative 6 times negative 5, negative 10 times negative 3, negative 15 times negative 2, and negative 30 times negative 1. And I need two things that add to negative 31. So I will choose the negative 30 times negative 1, because negative 30 plus negative 1 is negative 31. Therefore, this factors into x minus 30 times x minus 1. Okay, so those are the examples of just the straightforward type 1. The next two are variations that can come up that look a little different. And then the last two over there are what happens if you have other pieces that can be factored as well, right? So let's start with the other variations here. Notice this is not the same kind of trinomial. However, it is a trinomial, and that's your first red flag. Is it a trinomial? Does it have the 3 terms like the other patterns? Yes, it does. Okay? But it's not a squared and a linear, right? It's not a 2 power and a 1 power. That's okay. In trinomial factoring, as long as the higher power is double the middle power, right? As long as it's double, then you can still do this. And the only caveat, the only thing you have to worry about is whenever you pull up your parentheses in the answer, right? Because my answer is going to look like this. Normally we would put the letter there, right? But notice, normally in the middle is just an x. So that's what I put x and x here. I've got an x squared here, right? So I'll be putting x squared here and here. And notice how that actually works out. Because if I do x squared times x squared, I get x to the 4th. And then when I do the other cross terms, right, I'll get 2 different things that are x squared that can combine. So it works out. If you have something that's double, then you simply use the middle one as your front runner for each binomial. And then I'm going to follow the same patterns that we were doing before with the numbers. So for 21, I'll have 1 times 21, 3 times 7, negative 7 times negative 3, and negative 21 times negative 1. That's the whole list for that one. And I need to add to get 10. So that's going to be 3 and 7. So I can finish this up by saying x squared plus 3 and x squared plus 7 is my factorization. This is the actual factorization. Notice it still follows the same patterns. It's still a trinomial. It still has the same arrangement of powers. They're just physically different numbers for the powers, and that's okay. They can be, 10 and 5 or 14 and 7. As long as it's double. It can even be a 1 and a 1/2 power. That's for later algebra, but it does work. Okay, as long as that relationship is double, you can do this kind of factoring. Here, if it seems like you have too many letters, that's okay. Okay, you can still do the same factoring. You can just pretend the other letter doesn't exist. Here's what I mean. Pretend for a moment that you're factoring with only one of the letters. Z squared minus 13z plus 30. Okay? Just pretend that the y and the y squared don't exist. And it needs to specifically be like that, by the way. It needs to be a square on both sides and then one of each in the middle. It will actually follow the same pattern, okay, as one of the other trinomials, right? And normally in our answer binomial, you would put your letter in the front, z and z, right? Okay, fine. The only twist here is I really want to factor this guy here, and I just need to incorporate the y's. All that does is put a y at the end of each one, and then I still have to play the number game that I did before to fill in the number portions. But it's exactly like factoring this one. So for a moment, pretend you're factoring this one here, right? Z squared minus 13z plus 30. We've already got a list for the 30 over there, right? So what are two things that add to get negative 13? Wouldn't that be negative 10 and negative 3? So then that's what I put here. Minus 10 and minus 3. Okay? Notice it works out. Z times z is z squared. I've got negative 3zy and negative 10zy, which will give me a negative 13zy. And negative 10y times negative 3y would give me 30y squared. Okay? Don't forget that to check yourself, all you have to do is multiply it back out, foil it back out, right? So this is the factorization for that one. You just need to kind of come down a notch and realize that having that extra letter there, as long as it follows that pattern, doesn't change any of the stuff I've been doing. Everything we do is this number game on here, right? We just worry about the number portions. The letters just have to fit the correct pattern. Right? There needs to be a trinomial, there needs to be a high power and a low power, and the higher power just needs to be double the lower power. And if you have multiple letters, they just need to follow that mirror image pattern, right? Where the squareds are on either side and they have one of each in the middle. It's all the exact same factoring pattern. Okay, these last two examples here are just ones that have extra factoring in them. All right, yay, extra factoring, right? So look, what I mean is this is not something that fits those trinomial patterns because 3 is not double of 2. Also, this isn't a constant term on the end. Hey, wait a minute, they've all got an x. I can GCF an x out. And that's what I do. I pull an x out first. That gives me x squared plus 3x minus 4. Like this. Now, this x is just along for the ride. It's just going to follow me all the way to the answer. You can forget about it until the end. I'm going to focus inside of the parentheses. Can I factor that more? Probably. Let's make a list for negative 4, right? So for negative 4, I'll have 1 times negative 4. I'll have 2 times negative 2. There's my repeat. So then 4 times negative 1, and that's my whole list. And 4 times negative 1, 4 plus negative 1 is also equal to 3, right? So that's what I need for this guy. All right? So just this piece right here, this this part right here factors into x plus 4 times x minus 1, right? That's the two numbers. And then don't forget, this guy was already there. I factored him out earlier. So I've got 3 pieces to my factoring there. Okay? Rule number 1 in all factoring. Okay? From now on, remember, always look for a GCF first. This does 2 things. 1, it makes some methods possible. See, before we couldn't do the trinomial method. 2, GCF also can make the patterns nicer, simpler, easier to get through. Okay? And that's an example in this next one. Notice this one doesn't even seem to be the type 1. There's a number other than 1 in front of the higher power here. However, I notice 5, 25, and 30 all have a common factor of 5. They also all have x's. So remember, you're going to take the lowest power, x cubed. So I start by doing that. 5x cubed times. Here, 5 divided by 5 gives me just 1x squared, right? 25, negative 25 divided by 5 gives me 5, and then x, because 4 minus 3 is 1. And negative 30 divided by 5 is negative 6, and I took all 3 x's. So just like before, if you're able to pull a GCF out, do that first, always. So I did. That chunk is just going to follow me to the answer now. Okay? That 5x to the third is just along for the ride. You can forget about him up until the final answer. Make sure you include him in the final answer. Okay? And it's important because later on I'm going to show you a method where I GCF something out and we end up throwing things away sometimes. Okay? If you ever GCF something at the beginning of a problem, always, always keep that. That is a chunk that's part of the original problem. Okay? So that's going to follow me down. Now, I just need to make a list for negative 6. Easy task, right? Negative 6 is going to be 1 times negative 6, 2 times negative 3, 3 times negative 2, and 6 times negative 1. I need to add to negative 5. So that would be 1 and negative 6. Because 1 plus negative 6 is negative 5. Therefore, I can use the x plus 1, right? That's the 1. And x minus 6 from the negative 6. And then the 5x to the third is still there, right? Because that was an original piece. So then here's my factorization for that guy. It's time to generalize this method to the type 2. So what we're going to be talking about are trinomials that need to be factored where the leading coefficient is not 1. What you need to realize is this is essentially the same method, but I'm having to take greater care with the intricate steps in the middle. I'm not able to just skip to the end anymore. But it's actually the same method, okay? So I'm going to show you how really it's just a generalization, and the more you practice both of them, the way they'll feed each other, okay? Now, also, there's about 7 different ways that people I've seen have approached these and made little games or made, ways of writing it down and understanding it. I'm going to show you 2 of them. And then in the next scene, for all of the examples, work the one way that I typically do the most. Okay? If you have a desire to see any of these other ways, then, subscribe and send me a message and I can make another video. But for now, I'm going to show you the main method, which is typically the algebraic method that's written in books. And I'm going to show you the way I typically do it because the way I do it mimics the type 1 and also cuts a lot of your time shorter for completing these problems. Okay, so here we go. 2x squared plus 11x plus 12. I can tell that it's the second type, that it's the more generic type, because there's a 2 in front of the x squared, not a 1, and I cannot GCF anything out. Remember, the first thing you should always look for is a GCF, a common factor that I can pull out of everything. Be sure that you are looking for that first. And there is not one here. 2, 11, and 12 do not have any common factors. Okay, so both of the methods that I'm going to show you are in the family called the AC methods. Okay, and what that means is it sort of helps you along without having to look at lots of different patterns. The AC method attempts to really hone in on the 2 numbers that you need really quickly. So I need to incorporate this front number called A, and I'm going to do that by multiplying A times C, right? So 2 times 12. And that's why it's called the AC method, because I'm multiplying A times C. And that's always how you're going to start these things. Now, real quick on the side, think about this for a second. If I were to do the AC method on one of the type 1s that we did earlier, notice it would be 1 times whatever the constant number is, which would give you the same constant number back. And then, as you'll see in a moment, it still falls in that same category. So technically, you could do this AC to the earlier ones as well, and it won't change a single thing. Because look, this is what I'm going to do. When I multiply A times C, in this case, 2 times 12 gives me 24. And then what I'm going to do with this number is the same thing that we did with the constant term before. I'm going to create a list now of all the things that multiply, and then I'm going to look for things from that list that will add to the middle number 11. So this is actually the same process. I've just added an extra step of multiplying the front number times the back number, the square number times the constant number, the A times the C. Okay, so let's make our list. Let's count, right? 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then 5 doesn't go, so 6 goes. So then I'm just repeating, but now with the negatives. Okay, so then that would be negative 8 times negative 3, negative 12 times negative 2, and negative 24 times negative 1. Okay? So same method there as before, and same idea. I want to find 2 numbers that multiply to 24 that also add to 11. So that's going to be the 3 times 8 right here, because these add to positive 11. So from here, I now cannot, I'm not just going to do like I did before and put 2 parentheses with X. I can't anymore, okay? One of them had to have a 2 in front of it. So method number 1, the official algebra step-by-step method that's listed in most textbooks, is the one that I briefly showed you earlier, which uses grouping, right? And to use grouping, it's going to unadd this middle term, right? I'm going to unadd 11x into the 3x and the 8x. So that's 2x squared plus 3x plus 8x plus 12. Okay, so it's the same polynomial as you can see. From here, I just use my grouping method. The front 2 here have an x in common, leaving me 2x plus 3. Match the middle sign. 8 and 12 have a 4 in common, leaving me 2x plus 3. I notice that they both have the 2x plus 3, so I factor that out. And it leaves me with x plus 4. And so this is the factorization of that polynomial. 2x plus 3 times x plus 4 is the factorization of 2x squared plus 11x plus 12. And don't forget, you can check by remultiplying it back out. Okay, so That's the official algebra method. Let's talk about the way Professor Simon does it. And you can pick which one you like better. So I have my 2x squared plus 11x plus 12. And just like before, I would do the a times the c, 2 times 12, and make my list, and then find the two numbers that add to 11. All of that is the same, okay? You really need that method to pinpoint with a lot of accuracy the pair that you need, okay? This is a quick and efficient way of pinpointing exactly the values you need without having to play extensive games and look for random patterns and always have to check left and right and say, did I do this right? This is a very efficient method for doing that, okay? However, once I choose the 3 and the 8, I like to go back to the other method where I can just write the two parentheses bubbles, right? So we like the method that I can go from this and just write the two parentheses, right? And then I would normally take the 3 and the 8 and put them at the back side. So again, I haven't changed it much from the type 1 method. I can go straight to the parentheses, right? We love that. Except, normally I would put an x and an x, right? That would be the old method. That's like putting 1x and 1x. But I don't have 1x squared anymore, do I? I have 2. So here's what I do. I take whatever that number is in front, the 2, and I copy it both places. 2x and 2x. Okay? Now wait a minute, Professor Simon. 2x times 2x is 4x squared. That's wrong. Correct. This is not correct yet. But here's the thing. When you multiplied a times c, you mixed together all of those different little pieces between a and c, and then sprinkled them all throughout these factors here, okay? There's an extra 2 floating in there because of the way this was multiplied, okay? So I need to figure out where the extra 2 is, okay? Whatever a is the extra because I multiplied it here. So there's got to be an extra a floating around in here somewhere, and our a happens to be a 2. So here's the way it works. Whatever's extra will be noticeable by a GCF. Now be careful. If there was a GCF before, you're going to make a mistake. You must have all original GCFs taken out first and saved. Because what I'm about to do is use GCF to throw something away, an extra. 2x plus 3, nothing in common. 2x plus 8, they have a 2 in common, don't they? So look, if I do 2x plus 3 and then x plus 4 times 2, notice right here, between these two pieces, I factored a GCF of 2 out. Okay? But this 2 right here should not be there because it was the extra 2 that I incorporated with my little maneuver with the AC here. Okay? So basically, you can just throw that guy away. And notice I get the same answer. 2x plus 3, x plus 4. Okay? It's not magic. It's taking into account that doing the a times the c brought in an extra a piece. And then this is basically what I call filtering out the extra a, right? I'm going to filter out the extra piece there and then throw it away. Sometimes you have to do a little bit in each bubble, and sometimes it's all at once like that. Okay? It's different in different problems. But notice, if you know how to do that filtering step, you can get to the answer a lot quicker without having to write out all the steps. That being said, if you're a person that likes to see the steps and you want to practice the grouping method, by all means do this. It's a very sound, good method. Okay? Personally, this was a very easy method for me to be able to visualize whenever I was practicing and learning and growing. And it's still the way that I personally picture it. And there's at least 5 other methods out there using magic squares and doing games with first and last in line. And there's you know, some people like to call them drop numbers, where they list out numbers underneath and check them. Different methods are for different people, but these are the 2 that I officially stand by. Okay, let's do it again on this one. I'm going to multiply A times C, 6 times 1. That's going to give me 6. I'm going to make a list for 6. 1 times 6, 2 times 3, negative 3 times negative 2, negative 6 times negative 1. Okay, so there's my full list for 6s. I need to add to negative 5. So I see negative 3 and negative 2 are my victims here. I'm going to unadd the negative 5y into 6y squared minus 3y minus 2y plus 1. I am then going to group, which here 3y is common, leaving me y minus 1. Match the middle sign, minus 2y and 1. Oops, I made a boo-boo. I hope you caught me. 3 times 2 is 6. So here, minus sign matches, but nothing else in common, so I put a 1. Negative 2 divided by negative 1 is positive 2. 1 divided by negative 1 is negative 1. I notice that they both have the 2y minus 1 in common, so I pull that out, leaving me with 3y minus 1 as the answer. Okay? Now, the same polynomial, 6y squared minus 5y plus 1. And remember, the beginning is the same. I still do the AC, which would still give me the 6, which would still eventually lead me to negative 3 times negative 2 as my pair of numbers. All of that is the same. However, in the other method, I write my bubbles, right? My double parenthesis bubble. And I copy this front number, 6. 6y minus 3. 6y minus 2. See, I'm taking those 2 values, the 3 and the 2, the negative 3 and negative 2, and I take the front number, a, and put it in both. And remember, this is incorrect, but I'm going to filter it using some GCFs. Okay? 6 and 3, they have a 3 in common, leaving me 2y minus 1. And 6 and 2, they have a 2 in common, leaving me 3y minus 1. And then I basically throw these away, leaving me with this factorization. You may notice it's really essentially the same thing that's going on here. It's just writing less of the steps officially, and it's sort of just more of a visual method. I guess maybe that's why I get into it more. Okay? Now, the next one you have to be ultra careful with. Okay? There is a GCF this time. You must take that GCF out first for many reasons, okay? But especially if you're going to do this method that I use most of the time, you must get the GCF of the original problem out first and set it aside, and remember that it is part of the answer, that you do not throw it away, okay? Right here, throwing these away, part of the filtering step, okay? Because it's in the middle in there, and those are the extra. But if you get a GCF out at the beginning, it must follow and be part of the answer at the end. Okay? So here's this one. I notice that I can get a 3 from everybody. And I notice I can get an X from everybody, leaving me with 2y squared plus 11y minus 6. Okay? So don't forget the 3x, I'm saving that, and then that's going to be part of the final answer. So then what I'm really doing here is I'm really factoring 2y squared plus 11y minus 6. That's the one that I'm factoring. Okay? So let's do the AC, which is going to be 2 times negative 6, which is negative 12. And I'm going to do my list. 1 times negative 12, 2 times negative 6, 3 times negative 4, 4 times negative 3. And there's your repeat, right? I've counted up. And everything after this is just going to be the mirror image. So I'll do 6 times negative 2, and then 12 times negative 1. And I need 2 things to add to 11. And notice we got to it finally at the very end. 12 minus 1 is positive 11. So that's the pair of numbers I'm looking for there. Okay? So I will do this also with both methods. I'm going to unadd the 11y. So 2y squared plus 12y minus 1y, which you could also do as just minus y, minus 6. 2y is common here, leaving me y plus 6. Here the negative has to be matched, and it's also common to both, but just the negative, so I put a 1. Also leaving me y plus 6, which I can therefore write as y plus 6 times 2y minus 1. Okay? Or if you choose to do this one the other way, 2y squared plus 11y minus 6, I would put both parentheses starting with a 2y, and then I still have the 12 and negative 1. 2 and 1 don't have anything in common, but 2 and 12 do. So I take the 2 out, leaving me with y plus 6 and still 2y minus 1. I throw away the extra, and then I'm done with that factoring method. Okay? But we need to write the official final answer. Don't forget, this 3x is part of the answer. So, final answer here is 3x times y plus 6 times 2y minus 1. It's the official final answer there. Let's work some more examples of this second, more general type of trinomial. I'm going to be using the method that I typically use, which is the double parentheses with the filtering. Okay? So 35x squared plus 4x minus 4. Remember, I start with the AC method. So that's going to be 35 times negative 4. So we're looking at negative 140. And then I just need to find 2 numbers that add to 4, right? So I've got 1 times 140, 2 times, oh, it's negative 140, my bad, negative 70, 3 doesn't go, 4 goes, we just saw because we used it, negative 35, 5 goes, right, because 5's in 35, so that's going to be negative 28. 6 doesn't go because 3 doesn't go. 7 is in 35, right? So 7 will go, times negative 20. 8 doesn't go. 4 goes, but not 8, because 35 is not even. 9 doesn't go. 10 goes, right? 10 times negative 14. 11, 12, 13, and then 14. So notice we've hit the repeat, right? So 20, negative 7, 28, negative 5, 35, negative 4, 70, negative 2, and 140 times negative 1. And we need to add to 4, correct? Therefore, I'm going to do 14 times negative 10. So then I'll get my parentheses here, 35x plus 14 and 35x minus 10. 35 and 14 both have a 7, so that's going to leave 5x plus 2. And 35 and 10 both have a 5, which would leave 7x minus 2. A couple of things to look for. Remember, 35 is the extra because I used a. 7 times 5, the things that I factored out here, is 35. That's the extra. Get rid of those. So my final answer is 5x plus 2 times 7x minus 2, right? Remultiply it out, you'll see that you'll get the original polynomial, right? Got my 35x squared, got my minus 4, and then 14x minus 10x in there. Okay, what if there's a negative in front of the a? That's okay. You don't actually have to do anything special. Some people like to. Some people say, oh, I want to pull a negative out front and just make everything positive. You don't need to, okay? With the AC method and the way I'm showing you this, everything works out just fine. Okay, you just need to be able to keep track of your negative signs. So negative 5 times 4 is negative 20. Okay, so let's make a list. 1 times negative 20, 2 times negative 10, 3 doesn't go, 4 goes, 5 is the repeat, so I'll begin to mirror everything now. 10 with negative 2, and 20 with negative 1. I need a negative 19, so that's going to be 1 and negative 20. Okay, so then the front of each of these parentheses should have a negative 5x. So then I have plus 1 and negative 5x minus 20. Okay, so then right here, notice negative 5 and negative 20 both have a negative 5 in common. Right? Both of those have a negative 5 in common, which would leave me with x plus 4. And then I just throw away the extra negative 5. So this is one version of an answer right here. Negative 5x plus 1 times x plus 4. Some people may also have pulled the negative out early in the beginning, in which case the negative would be sitting in front here, and you would have 5x minus 1. And that's okay. You can have that too. Remember these patterns from before? Okay, there's no GCF here, right? 14, 3, and 2 don't have anything in common, and the letters aren't all throughout, but it's that mirror pattern where I have the squares on either side and one of each in the middle. Remember, you can factor those by pretending that one of the letters isn't there. So in other words, pretend 14a squared minus 3a minus 2 is the thing you're factoring. Okay? So then in the next step, after I do all of my other stuff, notice that I'm going to be putting a 14a in front of each of these bubbles that I'm going to do and factor. But when I reach the final answer, okay, the final answer is going to have A's and C's. Okay? I bring the C back and just put it at the end. But it's the same pattern as the other one. Okay, so let's work it. A times C is going to be 14 times negative 2. That gives me negative 28.
So I've got 1 times negative 28, 2 times negative 14, 3 doesn't go, 4 goes times negative 7, 5 doesn't go, 6 doesn't go, 7 is the repeat. So I got negative 2 and 28, negative 1. They need to add to get negative 3. So I will take 4 and negative 7. Alrighty. So then I'm going to put plus 4 and minus 7 in my parentheses here. And I'm noticing that the 14 and the 4 have a 2 in common, leaving me 7a plus 2. The 14 and the 7 have a 7 in common, leaving me with 2a minus 1. So then to convert that into the final answer, I'm going to have 7a still, but now I'm going to have plus 2c. And then right here I'll still have 2a, and then minus 1c. Notice I threw away the extra here after I filtered it out, right? So here's my final factorization there. Okay, let's do it again. Remember, you're going to pretend that this is 9a squared plus 24a plus 7. And then at the very end, I'll just bring the x's back. Also, don't forget to check for GCF, right? 9, 24, 7, no factors in common, no letters in common, anything like that. Okay, so AC, 9 times 7 is 63. So that's 1 times 63. 2 doesn't go, 3 goes, right? 3 times 21. 4 doesn't go, 5 doesn't go, 6 doesn't go, 7 goes, right? Times 9. Okay, 8 and then 9. So then I get my repeat. I'll do negative 9 times negative 7. Then I keep repeating negative 21 times negative 3, negative 63 times negative 1. I need to add up to 24, so I'll pick 3 and 21. Alrighty. So then I'm going to stick with blue while we're in the little alternate problem here. 9a plus 3 and 9a plus 21, right? Taking the 9 and writing it both places. 9 and 3 have a 3 in common, leaving me with 3a plus 1. 9 and 21 also both have a 3 in common, leaving me with 3a plus 7. I'm going to throw away both of these filtered out pieces, right? And I want to make it back to the official answer that has the x's in it. So I will have 3a plus 1x and 3a plus 7x as my final answer here. Okay? Now let's talk about a couple of examples that have GCFs in them. Remember, since I'm using the method that also uses GCF to filter out pieces that I don't want, I need to make sure and remember anything that I GCF at the front, at the beginning, does not get filtered out. And also I need to double check that there is a GCF so that I don't throw away the wrong thing in the middle. All right, so 6, 7, and 5, no GCF, but everybody has a y in there, right? So I'll pull the y out, leaving 6x squared minus 7x minus 5. AC method says 6 times negative 5, which is going to give me negative 30. And I'll make my list. 1 times negative 30, 2, 3, 4, doesn't go, 5. And there's my repeat. 6 times negative 5, 10 times negative 3, 15 times negative 2, and 30 times negative 1. Okay, Also, don't forget that I'm just going to keep this y sort of in the back, but it's going to be in the final answer. So whatever my final answer is, okay, that's going to be where it is. So let's do a momentary side note here. The 6x squared minus 7x minus 5. I need two things that add to negative 7. So I'm going to pick 3 and negative 10 here. Okay. So then I've got 6x plus 3 and 6x minus 10. 6 and 3 have a 3 in common, leaving me with 2x plus 1. 6 and 10 have a 2 in common, leaving me with 3x minus 5. Okay, so of course these get thrown away, right? The filtered out pieces get thrown away. And then I can write up my final answer. Don't forget the original GCF of y. And then I've got my 2x plus 1 times 3x minus 5. And then that would be my final answer. Okay, one more. 12, 10, and 42 all have a 2 in common. And everybody has x's, so I take the lowest power. That would be x to the 3. Leaving me with a 6x squared plus 5x minus 21. Right? Okay. Now I'm going to pull the AC method. So 6 times negative 21. Right? So that's going to be negative 126. Because 6 times 20 is 120, and then plus another 1 times 6. Okay? So I have 1 and negative 126. 2, obviously, right, because it's an even number, will be 63, negative 63. 3 and negative 42. 4, no. 5, no. 6, we've used already, right? 6 times negative 21. 7, yes, because it's in the 21, will be negative 18. You may have noticed throughout some of these that I've said, oh yes, I know this number goes and this number goes because it's a part of. What I'm basically envisioning is that a 6 is a 2 times 3 and a 21 is a 3 times 7. So I know that 2 and 3 and 7 and 3 are going to all work, right? Also, since both of them have a 3 and I'm multiplying, 9 is going to work. 8 doesn't work, but 9 does work, right? That's going to be 14. Because basically I'm just swapping the 2 out of the 18 there for that one. Okay, 10 doesn't work. 11, no. 12, no. 13, no. 14, and then I get my repeat, you see? So 14, right, times negative 9. And I'm just going to go ahead and stop because I'm noticing, right? Normally I'd go ahead and write the whole list out, but I notice 14 minus 9 is 5. Okay? So, by the way, you don't have to write the whole list out. If you see it, right, and you want to save time, boom, once you hit that one that you recognize is going to be your player, then go for it, right? Okay. Now remember, the 2x to the third is a keeper. This is going on to the final answer. So I'm going to keep that piece. This piece right here I'm going to factor by doing 6x plus 14 and 6x minus 9, right? Taking my two numbers there and doing the 6's with each one. 6 and 14 have a 2 in common, leaving 3x plus 7. And then 6 and 9 have a 3 in common, leaving 2x minus 3. And then, of course, those filtered pieces are the ones that I throw away, right? Those are the pieces that I don't use. The original GCF I do keep. Okay, final answer. 2x to the third times 3x plus 7 times 2x minus 3.
I'd like to finish up with 3 more examples that are sort of a crossover for some people. I personally, when I teach this subject, don't actually show or even, well, I point it out like I'm doing now, but I don't actually consider this a separate lesson. Basically, there's a small little pattern that you can come across every now and then. And really the only good use of this pattern is in case the numbers are really big, which they tend to be with squares. But the main thing to realize is that these can also be worked perfectly with the methods that I've already demonstrated in this lecture. Okay, so take a look at these real quick. The pattern that I'm referring to is called a perfect square trinomial. Okay, anytime you have a perfect square trinomial, it would be 2 of the same thing, a plus b squared. Okay, if you put a plus b times a plus b, you get a squared plus 2ab plus b squared. Anything that follows this kind of pattern, okay, which by the way, it can also have subtraction if your a's or b's are negative. If this happens to be a minus, then this will happen to also be a negative, a minus there. Okay? So factor this one the way that this is insinuating here. The only way this is going to work is if you see things that are squared on both sides. I see x squared and I see 100, which is technically 10 squared, right? I see this is 10 squared right here. So if I follow this pattern right here, the only way this is going to work is if the middle is double the 2 things that are squared multiplied together, right? So x times 10 doubled is 20x. So this one does fit that bill. So in other words, I should just be able to take the 2 things that I see squared, the x and the 10, and then factor this into x plus 10 squared. And you'll notice if you factor this one the old way that we were doing before, I would have gotten 10 times 10 is 100 and 10 plus 10 is 20. So I would do x plus 10 and x plus 10. So I would get x plus 10 squared. Okay? Here, I'm going to factor this one the old way and then also show you the perfect square way. Right? So the way that we demonstrated before, I would do the AC. So that would be 25 times 4 is 100. Right? And then I need 2 things to multiply to 100, which would add to negative 20. Right? So I'd start with 1. 2 goes, 3 doesn't go, 4 goes, 5 goes, 6 doesn't go, 7 doesn't go, 8 doesn't go, 9 doesn't go, 10 then goes. Right, and I have 10 times 10. The repeat would be negative 10 times negative 10. And that's your tell right there. Do you notice negative 10 and negative 10 add to give me the negative 20? Because I'm using a duplicate like that, should tell you that this one does actually fit the perfect square because it's going to be 2 of the same thing, right? So if I do this one like before, I would put my parentheses 25x squared. Remember, just you have to make sure and match the middle guy because 4 is double of 2. Minus 10. And then it's the same thing again, right? Because I picked 2 of the same number and a is the same in both of them. So then 25 and 10 both have a 5 in common. So I'll throw away both of those 5s. And notice I get 5x squared minus 2, 5x squared minus 2. If I do it the other way, the pattern way that
that we're talking about here, then what I would need to notice is what's being squared in each piece, right? So 4 is 2 squared, right? I'll write the square on the outside like this. And 25x to the 4th is 5x squared all squared. Okay? So 5x squared times 2 is 10x squared, is it not? Right? Because 5 times 2 is 10. And if you double that, remember you have to double it, double of 10x squared is 20x squared. So that means it fits the pattern. So then you literally take 5x squared and 2, and you just match whatever that middle sign is, squared. And notice that's exactly what we came out with. Okay? So what this is this is another pattern of, if you just happen to notice it. If you totally don't, remember this pattern later on, no big deal. As you can see, I can still factor these with the other methods that we discussed. Let me close up with one more that has a GCF. I can GCF the 2 out, right? 2. That will leave me with 4x squared minus 20x plus 25. Okay, so if you're going to do this one with the old school, right, notice 4 times 25 will give me the 100. It's going to be very similar to this. Okay, let me do it with the pattern way, since this is an example of that. I'm noticing that 4x squared is the quantity 2x being squared, and 25 is 5 being squared, not fifth power. Right? 2x times 5 is 10x, and if you double that, you get 20x, which means this does fit that pattern. So I would literally take the 2x and the 5, right? Square it, match this middle sign here, and then don't forget, this was an original GCF. It stays, so it would be out front. And then that would be your final factorized answer, okay? Don't forget that a parentheses squared literally means I have 2 of those parentheses, right? 2x minus 5, 2x minus 5. I hope this lecture has helped you in studying how to factor trinomials, because these are really the most common factoring that we end up with, other than GCF. These are very, very popular factoring pieces that come up a lot.